Okay, so now I'm continuing with part two for the science homework for Heart Academy of November 5th, 2018. So the next sheet, or sheet two, we talk about the mantle. So, I shall read. So, the mantle. Earth's mantle is a layer just below the crust. The mantle is the thick middle layer in the solid part of the Earth. The mantle contains more iron and magnesium than the oceanic crust does. This makes the mantle more dense than either the continental crust or the oceanic crust. The mantle is made of rock, just like the crust. Every time I hear the crust, I keep thinking like apple or cherry pie or something like that. Maybe some pumpkin pie. It's like the season for pumpkin pie, you know. Anyway, scientists group the mantle into four layers, and each layer, the rock, react differently when forces push up or pull on them. Alrighty, so here's the four different parts. Though we only talked about a couple of these parts in class today. But let's see, we can get even into more further details about the different sections of the mantle from this reading. So let's find out more information than what we already found out in class. Scientists group the mantle into four layers, right? In each layer, the rock react differently when forces push up or pull on them. The uppermost mantle. The uppermost layer of the mantle is made of hard rock. These brittle, rigid rocks are similar to the rocks in the crust. For this reason, scientists group together the crust and the uppermost mantle into a rigid or hard layer called the lithosphere. Oh, yeah. Did you hear that? Look, you should actually circle that. That's pretty good. And circle it and add it to your vocabulary book. That's a good one. And the asthenosphere, I think I'm pronouncing that one correctly, says the rocks below the lithosphere are so hot that tiny bits melt. When this happens, the rocks are no longer brittle. They begin to flow. When a material such as rock flows, scientists use the word plastic. The plastic layer within the mantle is called the asthenosphere. I was wondering what that was about, and now we know. So the ones we learned about today in class before doing this reading is the lithosphere and the asthenosphere. So these are the two that we actually learned about and labeled in class today with our drawing. Moving on. Okay. Let's see. Oh, wait a minute. We have checked so we can actually answer a question. Ta-da! Let's do this one. Compare. How do the rock in the lithosphere and the asthenosphere differ? I know how they differ. So we shall say. Wait, this here. Let's see. Put the asthenosphere. Asthenosphere. Happens when, well, I'm going to move this around. The tiny bits of the rocks, when the rocks from the lithosphere so hot they melt. That works for me. Or you can create your own sentence to compare the two spheres, the asthenosphere and the lithosphere. All right, now we're going to talk about the upper mantle and the lower mantle. The rock below the asthenosphere, shown below. The rock below the asthenosphere. So we're talking here. All right. The rock below the asthenosphere, shown below, is solid, even though it is hotter than the rock in the asthenosphere. How can it be solid when the cooler rock in the asthenosphere is plastic? The pressure below the asthenosphere is so high that the melting does not occur. High pressure squeezes the hot rock into a solid. This solid rock of the upper mantle and lower mantle form the largest layer of Earth. Interesting. What material make up the largest layer of the Earth? There you go. The salt. I will do it by voice command then, because our answer is right about here. This is the answer. The solid rock, the upper mantle, the lower mantle. Bam. So then, the solid rock of the upper mantle and the lower mantle form the largest layer of Earth. I love that. There we go. Even add a period. And moving on. Okay, so let's look at our visual check. Name the layers of the mantle shown in the figure. All right, so the layers of the mantle shown in the figure are here. The oceanic crust, the continental crust, the uppermost mantle, the lithosphere, and the regular part of the mantle. Layers of the mantle that are shown here. Okay. Uppermost mantle, the lithosphere. Oh, the asthenosphere. And the upper mantle. That one I'm going to have to redo because that one didn't pick up right. There we go. Oh. What's up? Okay. Oh, yeah. And moving down to here, let's talk about the core. Okay. So this says, hold on a second. I can't look at my talk. Not bad. DiGiorno. Pan crust. Dinner. Luna. Oh, you guys see the dog. The dog wants the pizza so bad. Luna. My dog. No, dog. I'm not giving you pizza. I just wanted you to come over. Alright. The core. The dense metallic center of Earth is the core. Imagine again that Earth is a hard-cooked egg. The yolk of the egg will be Earth's core. Earth's crust and mantle are made of rock. Why do you think the core is made of metal? Remember that early Earth was much hotter than it is now. Earth's materials flowed, just like they do in the asthenosphere. Remember, that's called plastic when they float. It's just like they do in the asthenosphere today. As you learned earlier in this chapter, early Earth was soft enough for gravity to pull the densest material to the center. That dense material is metal. The core is mostly iron with small amounts of nickel and other elements. It has a liquid outer core and a solid inner core. All right. So you see this key concepts checked. Here we go. Science use versus common use. Nickel. All right. Science use for nickel, a specific type of metal. Common use, a coin worth 5 cents. Now you know where nickel comes from. It's one of the elements on the periodic table, just like Shirley was saying and discovered today. On the periodic table chart that's in the classroom. Key concept checked. What are the interior layers of Earth? Wait, let's read these first. You learned that pressure is the lowest mantle let's go again, outer level. What is the interior layers of the Earth? That was up here. Interior layers of the Earth. The core and outer core. Or inner core, outer core. I think that's what goes here. Using voice. Using voice, not voice. Inner core and outer core. Now picking up from where it says outer core. You learned that pressure is the lowest mantle is great enough to keep the rock in a solid state even though it is very hot. How then could the outer core, where the pressure is even higher, be liquid? The answer is that the mantle and the core are made of different materials. These materials melt at different temperatures. Just as in the asthenosphere, the effective temperature outweighs the effective pressure in the outer core. Scientists learn that the outer core is liquid by studying what happens to earthquake waves when they enter the outer core. Inner core. Earth's inner core shows shown in the figure below, which is here. Earth's inner core, shown in the figure below, is a dense ball of solid iron crystals. The temperature at the center of the Earth is about 6,000 degrees Celsius. Because the pressure is so high, the iron is in a solid state. I'm looking at the news. Katrina, look. Honey. Hon. I got to pause it for a second. Alright, I had to pause it for a second. I got caught by something that was on the news. It was a really cute story of mother bear and a baby bear, so I had to watch it. Alright, and so I'm back. I have no idea where I left at. Oh, yep, the temperature at the center of the Earth is about 6,000 degrees Celsius. Because the pressure is so high, the iron is in a solid state. The liquid outer core is not tightly attached to the solid inner core. Therefore, the two layers of the core can spin at different speeds. The inner core spins a little faster than the rest of the Earth does. Ooh. Let's look at the key concept over here, check. Explain what evidence shows that Earth's outer core is a liquid. They spin at different speeds. All right, this question says, visual check, how do the arrows in the figure show that the inner core spins faster than the outer core? How do the arrows in the figure show it spins faster? Okay. So this would be, the longer arrow indicates it spins faster. There we go. Now, okay, let's take a look and see what we can do with this graph. Earth's core and geomagnetism. Have you ever used a compass? Nope, can't use a compass. I can't even use my GPS correctly. The needle on a compass points north. The metallic compass needle lines up with a force field around Earth. This force field, which is shown below, is caused by Earth's core. So the force field on how a compass works is caused by the Earth's core. So there's a force field this way, going this way, creating the magnetism that compasses use. Visual check. Well, let's read this part first. Earth's magnetic field. As you learned, Earth's inner core spins faster than the outer core does. This produces streams of flowing molten iron, also known as magma. Iron in the outer core. The movement of these molten materials produce Earth's magnetic field, and that's what should go here. Hypothesize. There you go, kid. Hypothesize. What do the arrows in the picture represent? I think they represent magnetism. Magnetism. And reading check. Here we go. Explain what creates Earth's magnetic fields. That answer is found right here. The movement of molten materials. Molten materials, not Vulcan. Okay.